lecture in this unit number 2, lecture number 15. So hopefully I will start the next unit from the next day. So this is the last lecture in this unit, and it is based on the architectural and low level design in software engineering. So architectural design, what is this architectural design? The architecture of a system describes its major components, because at the starting, whenever we are going to do the design phase, then we divide our software into different number of components, and we also concentrate over the relationships between the component and the relationship we can create with the help of the different type of structures. So the architecture of a system describes its major components. Okay, so we can say also that it is equivalent to some high level designing. So architecture, if I can consider the example related to the buildings. Okay, so architectural design means they include about the building, about the each and every space. Okay, means including the interior portion also. So architecture means the wide study. Okay, we can say the deep study of any building. So similarly, if we are going to talk in context of the software, then we can say the architecture, it describes all the major components and also the relationship among the components. So we divide our software into number of components. So that is called the architecture. So at the starting, during the design phase, we do the architectural designing of a particular project. So now here you can see, this is the diagram here. So software architecture. So this is one of the major part, that is the software architecture, and from this you can see a number of branches. Okay, so this is one of the core, we can say this is the interior, or we can say the core of the software if we are talking in context of the software engineering. Okay, so first, if we are going to implement any software, or we are going to implement any project, then here we can see this is the software architecture. After that, you can see a number of branches from here. Okay, so we can also call it is looks like the kernel. Okay, in context of the operating system, that is also the core, or we can say the interior part. Okay, so similarly in context of the software engineering, we can say this is the interior portion. Okay, and after that you can see a number of branches here. This is the design phase here. Okay, quality attributes, IT environment, human dynamics, and business strategy. Okay, so from this software architecture, you can see there are a number of branches which have the interface with the software architecture. So this is, we can say, the core of the project or the software. So this is the design phase again. So first we will do the architectural part similar to the building. Whenever we are going to design any building, then we concentrate over the architecture. So we can see there is another phase, or we can say another engineering branch. Okay, so similar to this. So this is one of the interior part, and after we are going to face the design, it has the interface with this. And now here we can consider the quality attributes. So there are number of characteristics. Okay, how we are going to maintain our software. So we always concentrate over the quality during the design. Okay, so ultimately the overall, the we can say the attribute is the quality here. We always consider the quality. of any product, not only software, but any product. So regarding any product, we always emphasize over the quality. And now, because this is related to the software engineering, then here we have the interface with the IT environment. Okay, now you can see, so what is going on outside, and we always check every time that what is going on. So this is IT environment, what is the environment outside your project, and this is the human dynamics. Now, because this has the interface with the software architecture, and accordingly we can change the phase or the architecture as per requirement of the human being, okay, the customer or the need of the organization. So we can change our architecture as per requirement of the human being or the human dynamics, or those who are using your software. Okay, we can also say like this. And this is the business strategy. So accordingly, here we are going to set the different type of planning or the strategy related to the business. Okay, so after implementation, how we will check the IT environment, what is outside, and here we can set our planning or the business strategy here. Okay, so here now you can see in this diagram, this is the core. Okay, software architecture, this is called. Now here we can see the architecture of a system describe its major components. Okay, so this is one of the major components and their relationship. Here you can see. So the major component this, and this is called the relationship. Okay, relationship with the design, quality attributes, IT environment, human dynamics, business strategy. Okay, so here we study during this phase, architecture phase, the relationship and how they interact with each other. Because whenever we are going to implement any software or the project, we divide into number of components. So we study at component level, and now there is a need arise to integrate all those components at the end. So how we are going to create the relationship and how we are going to join all those components at the end, okay, means there is a way to interact with all those functionalities of that particular project, okay, how those components are working. So this is called the architecture of a system. Now here you can see software architecture and design includes several contributory factors. We have already seen business strategy, quality attributes, human dynamics, design, and IT environment. Okay, so we can say that these are the various factors, contributory factors. Okay, because the software architecture is contributing all those factors which have the connectivity surrounding the software architecture, or we can say the dependability over the software architecture. Now again we can see here architecture serves as a blueprint. Okay, because whenever we are going to design any building, then first we design about the, or we can say generate the blueprint for that particular building. Okay, at very starting we can see even in the Polytechnic, just I am considering one of the example in context of the civil engineering. Okay, or we can say the architectural engineering. So in the Polytechnic, still we have some sort of machine, okay, that is a hardware, okay, mechanical system, so that how we are going to generate the blueprint for a particular system. So for that building, first we create, we can say, or develop the blueprint for a building, okay, and we can take the print out using that machine on a particular sheet, okay, maybe A4 size sheet. So or nowadays we can also take directly the printout with the help of the computer. So now there are number of software available for the blueprint. So in context of that architecture engineering, just I am telling in context of the software here, architecture serves as a blueprint. Okay, so means how we are going to generate the model, the initial model for a particular project. Okay, so architecture serves as a blueprint, means the initialization, the basic or the primary level, what are the need for a particular, we can say, the project. Okay, so here we are going to divide our software or the project into number of components. So we study and we create the blueprint for that. Okay, here the blueprint means we can say that we are going to generate a sort of algorithm, or we can also call the flow chart. Okay, so flow chart itself, mm, it is a sort of blueprint for a particular project or the software, because here just we are studying about the at the primary level. Okay, so it provides an abstraction to manage the system complexity. So how we are going to generate the project, then we can manage the complexity and establish a communication and coordination mechanism among the components, because we are going to divide our project for our facility. Okay, so that we can manage easily. We are dividing into number of components, or we can say into number of procedures or functions. So each function acts as a components. Okay, so we are going to divide into number of components, and after that there is a coordination mechanism among the components, because at the end we are going to integrate all those components. So that creates the communication among the components. So this is called the architectural blueprint, or we can say the architectural design, okay, for a particular project or the software. Now here we can see again selection of a structural elements and their interfaces by which the system is composed. Okay, so after dividing into number of components, we select all those structural elements and interfaces, because always there is a need arise to interface them or to connect those elements. Okay, so behavior as is specified in collaboration among those elements. So we always study about the behavior of each and every elements, composition of these structural uh, composition of these structural and behavioral elements into large subsystem. So here we are going to combine the structural, and we study about the behavior of each element into large subsystem. Okay, because we always combine all those components, and we can study about the subsystem and the system. Okay, whenever we will combine the different number of components, then we are going to form a number of subsystems. Okay, and at the end, whenever we will combine the subsystem, then we can form the system. So this is the architectural design. Architectural decisions align with the business objectives. Okay, so we always we study about the business uh, objectives, and that is interrelated to the architectural design. So architectural styles guide the organization. So we always study about the architectural design of a particular software. So it guides the organization. Okay, because this is the core or the internal part of any software. Okay, so first we can design, or we do the architectural design for a particular software or the project. Now we always study, because this is one of the factors which is related to the software design. But in unit number 3, I will always consider, I can again consider the software design, and we can elaborate this chapter. Here just we are studying only a little bit about the software design, because just we are not emphasizing over different methodologies related to the software design. So what is this? To negotiate system requirements. So whenever we are going to design any software, so we always must be aware, we can say, about the system requirement, what is the requirement of the system, and to set expectation with customers. So what are the different expectations of the customer, or before launching into the market, we will see what is the environment outside. Okay, whether there is a demand of a particular software or not. So before designing the operating system or other system software, the company always look outside, okay, and see what is the demand in the market, and what is the status or the value of the software which you are going to develop. So beforehand, any big company, any vast company always do the survey related to the operating system or any other system softwares. So during the survey, they find that there is a big demand of a particular software in the market, in the organization, in the institute. So before launching or before developing particular software, they highlight or they do the advertisement for particular big softwares, okay, system softwares. Before launching or before we can say 6 months or 1 year before, they started to advertise regarding the we can say the softwares, okay, so that everybody is aware by the what is now coming or about to come in the market, okay, name of the operating system, everybody is aware with the help of the advertisement, okay. So we can say we must negotiate the system requirement and to set expectation with customers, marketing and management personnel, act as a blueprint during the development process. Okay, so we always initialize and create some sort of the blueprint during the development process. Okay, if we are going to design or develop any software, then initially we create the blueprint for that. So guide the implementation task, including detailed design. So it also includes the detailed design, coding, integration, and testing. So these are the several phases which we have already studied about the design, coding, integration, and testing. So this is, we can say these are the different type of phases which we need during the development of the any software or any new software. So we have to study about the architectural design, detailed design, coding, integration, and testing. Now here you can see it comes before the detailed design, okay, coding, integration, and testing, and after the domain analysis, requirement analysis, and risk analysis. So now you can see a number of factors here, okay. So in the block diagram, you can see here now domain analysis, we will do this, okay, requirement analysis, risk analysis. So at the starting, we will study about the domain analysis, okay, at the starting means the we will do the architectural design, domain, we will do the domain analysis, and after that requirement analysis means what are the different requirements of the customer or the organization. Then we will also consider the risk analysis, okay, because whenever we will start to design any software, then we always consider the risk beforehand, or how can we manage the risk. So we will do the risk analysis in the first phase also, okay. And after that you can see here requirement, desire quality. If we are going here and trying to maintain the quality, desire quality, okay. So after that, we will do the software architecture design, and after this, hardware architecture and hardware architecture design here. So these are the different phases you can see. Now, if there is a need of the modification to the requirement, then we can again return to this phase, or otherwise here we can come or join to the detailed design, coding, integration, testing. So we can say implementation constraint. If there is some implementation constraint, then again we can return here, okay, because this has the connectivity with the software architecture design. Now we can change here if there is a need arise. After that, again we can change this hardware architecture design, and then we can complete our product. Okay, so these are the basic things. Here in the block diagram, we can see. Now, what are the different goals of the architecture? So the primary goal of the architecture is to identify requirements. Okay, again in each and every phase, we will check the requirement analysis. We do always the requirement analysis. So the primary goal of the architecture is to identify requirements that affect the structure of the application. Okay, so we always study about the requirement analysis even in the phase of the architecture. Now some of other goals here we can see: expose the structure of the system but hide its implementation detail. So just during the architectural phase, we can expose the structure of the system, okay, but what are the different implementation details we can hide, okay. We can hide all those implementation details. We are not going to expose our coding area, but we can expose the structure of the system. So during the study of the requirement analysis, we can form the one-to-one relation with the organization for which we are going to develop the software, or one-to-one relation with the customers. So we can expose even the structure of our system before then. Okay, but no need to show the coding or the implementation detail, how you are going to create or develop the code for that. Okay, so realize all the use cases and scenarios. So here we can realize all those cases which where we are using, and also all type of the scenarios which we can face in the future. So try to address the requirements of various stakeholders. So always we will check the requirements of the customers, of the organization, or we can say the requirements of various stakeholders. Handle both functional and quality requirements. So here we always emphasize over the functional and the quality requirements. So reduce the goal of ownership and improve the organization market position. So we will try to improve the organization market position. What is the market position of the organization in which you are working? Okay, so this organization in which you are working, so we will always try to improve the organization market position. What is the market position? So with the help of different methodology or the goals or the targets, we can improve the organization's market position. So improve quality and functionality. So improve the quality and functionality offered by the system. So improve external confidence in either the organization or system. So there are various improvement. We can enhance the quality or functionality, and also improve external confidence in either the organization or system. Now there are again a number of limitations. there are again number of limitations here, lack of tools and standardized ways to represent architecture. So these are called the various limitations, because in each we can say during the analysis or the design phase, we have the pros and cons, advantages and disadvantages. So there are always some sort of limitations in each field. Now we can say lack of tools and standardized ways to represent architecture. So still we have the incomplete tools or the lack of tools. Such type of tools are not available so that we can represent the architecture. Okay, like there are number of we can say the tools for the to generate the coding or for the testing purpose, for the design purpose. So there are number of tools, but still there is a lack of tools for the architectural design. So we cannot represent properly. Okay, so lack of analysis methods. Still there is a lack of number of methods, so that it is not so much easy to analyze our problem. And lack of awareness of the importance of architecture. So still there is a awareness, lack of awareness. Okay, we are not aware by the architectural design to the software development. So just we started our work and we never think about the core design of any software. Okay, lack of understanding of the role of software architect. So what is the role of the software architect? We are not aware by this. Okay, lack of understanding of the design process, design experience, and evaluation of design. So there are number of limitations here we can see. Now there is the two types of again after the architectural design. So there are again two parts: high level design and low level design. Okay, so this is the last lecture. So high level design, what is this? High level design in short, it is called the HLD. Okay, high level design is the general system design, means it refers to the overall system design. So we can also call this overall system design. Overall system design, it is also called the high level design. So what it is going to describe? It describes the overall description or the architecture. So this gives you the overall description or the architecture of the application. So this includes both. So high level design, we can say it may include the overall description. So overall description means it also includes the architecture of the application. Okay, so this comes under the high level design. So we can call the architectural design or the overall description. Okay, it includes the description of the system architecture. High level design includes system architecture, database design, brief description on the systems, services, platform, relationship among modules. Okay, so we always work on at the component level, and after that we form the module, we form the subsystem, we form the system at the end. Okay, so high level design, it includes all those things, including the architectural design. So architecture, it also includes the database design and brief description of system, services, platforms, relationship among modules. Okay, so this is you can called as the major uh, design. Okay, high level design means this is the major part. Now it is also known as the macro level or system design. So high level design, it is also called the macro level or the system design, because this is the overall design of the system. So it is created by solution architects. So it also includes the architectural phase. So we can say it is created by the solution architect. Here it convert the business or client requirement, because it also including the business or the client requirement into high level solution. So it is created first, means before low level design. So first here we create the high level design, and after that there is a low level design. Okay, now what is this low level design? Now come to this factor. Now low level design in short, like we can say the abbreviation for high level design HLD, for low level design it is LLD. Okay, So it is like detailing. HLD means it refers to the component level design. Okay. So it describes detailed description. So low level means just we are going to the interior side. It describes detailed description of each and every module. Okay. So during this design phase, we study about each and every module because we are working at the component level or at the module level. So we can say we study about the each and every module. So it includes actual logic for every system. Okay, low level design means actual level, or we can say actual logic for every system component. Okay, and it goes deep into each module specification. So this we can say here we are going to study deeply about each module. Okay, what are the different specification for a particular module? So it is also known as micro level, and in case of the high level and design, that is the macro level. Okay, macro and micro. So here we are going to study about each module. Just we are concentrating on each module, then it is called the micro level. Okay. Now here we can see low level design is like detailing. HLD means it refers to component level. Okay, low level design in short called LLD. It is also known as micro level. Okay, these are the number of important points so you can study. It describes detailed description of each and every module. So low level design have the idea or detailed description of each and every module. So it is created by the designer and developers. Okay, so low level design. This is the now we can also a number of points. Low level design participants are design team, operation team, and here implementers. It is created second means after high level design. So we always create low level design after the high level design. Okay, that because the level of high level design is higher than the this low level design. Okay, that time you are going to study about the system design, that is the studying about the at the system level. Okay, so here we are studying at the micro level, means at component level or module level. So low level design is related to the at module level. So in LLD the input criteria is reviewed here. Okay, low level design converts high level solution into detailed design. In HLD, the output criteria is a program specification and unit test plan. So high level and low level, what is the difference? You can see here. So this is all about this unit. We can say, just I am taking your attendance now. So any question, please, you can ask here. Any query? Yes.